This is a brief introduction to the Cloud DPE Development Studio. My name is Gene D'Angelo. I'm working from a client location in Southeast Florida using a standard PC, and I'm accessing a small server in Plano, Texas, about 1,000 miles away. The interface to Studio is made up of a series of tabs. This tab is the welcome screen we're now looking at. This tab is an import template. This tab is a program. If I diagram the data flow of this program, it also shows up as a separate tab. Another tab available is our Tables Explorer. This is very similar to Windows Explorer in that it shows tables in a hierarchical directory structure. It's at the top level for the My Tables area, which is a private area available to each user. Here is a subdirectory within that private area. The My Databases area contains tables that can be accessed by groups of users based on their security clearances. The My Shared Tables area allows users to selectively share their tables with other users. So if I go to this SDN subdirectory here, I can sort. Here is sorted by name. I can reverse the sort. I can also sort by date and in reverse as well. I can also sort by size. If I open up this largest table, you will see that it is a little over 500 million records. Again, I'm working remotely 1,000 miles away from the server, but I can scroll in this table anywhere I want to, all the way to the bottom. And of course, I can pan across as well. So you have access to the tables remotely in a very similar fashion you would if you were right next to the server. Another tab that can be opened up is the View Row Details tab. Of course, that tab can also be opened up just by double-clicking on a row. And as well, there is a Properties window, again, that shows up as its own tab, and it has subtabs for the schema, the indexes, other information about the table. So all this shows up again as a separate tab. If I go back to the Tables Explorer and open up the second largest table here, you'll see that it has almost 1 billion records. Again, I can scroll down anywhere I want to in the table. I can also take one of these tables and make it floating, which means it creates a separate window, which you can then put on any screen or any other display. And you can also, of course, show the two tables together for comparison. So that's one way you can use these. In addition to the tabs, you can also have floating windows that can be built from the tabs. If I go back to the Tables Explorer, another option I have for the Tables Explorer itself is I can make it dockable, which means I can put it over here. I can also make it auto hide. And now I can simply access the Tables Explorer anytime I want to, just by clicking on it or hovering over it. And if I click inside another tab, it will disappear. Okay, I'm going to close this table. And let's say I have some data I want to bring in from my client. Here's some data called customer data. If I look at this data, I can see that it is comma delimited with carriage return line feeds at the end, and the first row contains the column headings. Okay, so to bring this data in, I simply open up a new import template, leave the name at the default, change the column separator to comma. It's already carriage return line feed for the row separator. I'm going to skip one row because the first row contains the column headings. And I'm going to use the auto create template function in order to analyze the data and create a template. This template has over 500 fields in it, 500 columns. I can now run it. I'll use the name customer test, access the data, and it will bring the data in from the client in only a few seconds. So here we have the data, all 500 columns of it. So this is how you can quickly import new data from the client. Another option is to import data from the server, which you'd want to do for larger tables. This is an import template I have that matches a data file on the server. I'm going to run it and access, this time, data from the server. Here is a source file about 4.3 gigabytes in size. I'm going to bring that in. It'll take about 16 seconds to import this table. It's about 57 million records in the table. You'll notice this progress bar here that appears whenever we run programs and we do imports and so on. It tells you how far along you are in the process. Here's our table, about 57.7 million rows. And again, you can scroll down anywhere you want. Okay. Now, if you look at that table in the Tables Explorer, here it is here, we'll see it's about 325 megabytes in size, which represents about a 14:1 compression ratio from the 4.3 gigabyte size of the source data. Now I want to show you a program. This is a program, a fairly complex program that took 2 or 3 days to develop. The objective of this program is to develop a network topology that looks like this. It has nodes in different cities and connections between different cities and so on. The parameters used to determine the topology are expressed in a number of variables. These variables indicate things like the latitude and longitude rectangle that you want to develop the topology in, and the distance between switches, the number of ports on each switch, the size cities that you want to put switches in, and so on. So, and the number of IPs that you want per population. So this is this program does this work. You can see that a program actually has a hierarchy of tabs. These are tabs for each process. These are tabs that show the tables going into each process. So if to show you how this actually fits together, I have a little diagram here that I'll bring up. And each process can have any number of input tables. Each input table can have its own filter. Every field coming in, every column coming in from the table can have an input formula to modify the contents. Then there is a number of database operations that can be performed on the input tables. You can have any number of output tables going out. Each of the output tables can have their own filter. And each output column can have a formula that modifies the output of those columns. And of course, you can have calculated columns and so on. So these processes then fit together, one after another, to form a program, or what we call a seed. As you can see, this seed has a number of processes. Each process has input and output tables. Over here we have a process with 2 input tables and 2 output tables. An important part of this seed, as I mentioned before, there are calculated fields and there are filters and so on. All these calculated fields and formulas use an expression builder. It's the same throughout. The expression builder uses a point-and-click mechanisms to build the formulas. You have access to all the different columns here. You have a number of special functions here that are fairly unique to this particular area. So one called a previous function, which is a very rare construct in this type of programming. You have, of course, logic and calendar functions. You have string functions, and you even have over here you have fuzzy logic functions as well, which is built into the expression builder. So it's a very robust expression builder that's used for all of our filters and our formulas. And it also puts these formulas in little boxes, which make them easy to modify and enhance your seed as time goes on. Now I want to develop a simple program in order to illustrate the point-and-click rapid application development features of Studio. in my tables, I have a subdirectory called healthcare, where I have some publicly available healthcare data. This particular table here, I'll open up, and you'll see that it has in the first column an NPI, which is a national provider identifier. It identifies the provider. This is either Medicare providers, Medicare Part B providers, or physicians, not hospitals, but physicians. This is the HCPCS code. This identifies the service render, the procedure that's performed by the provider. Over here is a year. This covers both 2012 and 2013 in separate rows. And for each of these provider, service, code, and year combinations, we have a total billed amount, allowed amount, and paid amount. All right, so what I want to do is first I'm going to open up a new seed and bring that table into the seed. I can add all columns, but I don't want to do that in this case. I'm going to bring in the service code, the HCPCS code, the paid amount, and the year. I'm going to put a filter on the year, so I only want 2012. And I'm going to sequence the code and make it unique by doing a union. And in doing so, I'm able to subtotal the paid amount. Then put an output file. I'm going to accept the default name, and now I can run this. This table has about 18 million rows in it. As you can see in the run statistics here, the seed brought in 18.4 million rows. It put out about 6,000 rows, and it took about 1.76 seconds to run. Now, I'm going to close this. What I want to do now is find out which of the HCPCS codes had the highest total amount paid for 2012. To do that, I simply appear at a new process, add a seed output. What I'm doing here is getting a list of all the tables from the prior processes in the seed. I'm going to add all columns in this time. Do a descending amount. Add an output. Again, accept the default names. This time I can just run this one process. So you run this process. And we have now a list of the total amount paid in 2012 for each procedure code. Here's one called 99214, which shows that almost $6 billion was paid in 2012 for procedure code 99214. Now, it might be interesting to know what these codes actually stand for. So we have a reference over here, a HCPCS reference. If you take a look at that, you'll see that for each code, it contains a description of what that code stands for. So what I want to do is I want to attach this description to the summary that I created. To do that, let's go back to my seed. I'm going to close this also. Go back to my seed, add another process. I'm going to bring in that HCPCS reference code. I'm going to do not add all columns at this point. Then I'm going to bring in a seed output. I am going to go back, in fact, and bring it in from the first process. The second process is simply a resort of the first process. Add all columns. And now go back to the first table. Bring in the HCPCS code and the description. You'll notice that the HCPCS code now has an asterisk, which means that it's coming in from both tables. And we can now join on that. We can join on that, and we can by doing an add columns join, we can attach the description to the code. And perhaps I now want to move this up to position 2, just to make a better report, and add an output. Set the default name again, and now I can run this process. Already had to run the process. And you'll see that now we have, for each of these codes, we have the description attached to it. All I have to do now is get another process to sort it, add the seed output, all columns, descending paid amount, output, run this process, and now we'll find out that the $6 billion here was paid for and what they call evaluation and management HCPCS code, which is understandable. These are the office visits you normally get whenever you go to the doctor. And so these are different intensities of that. But that's what most of the money was paid out to physicians by Medicare in 2012. Now let's say we want to maybe do the same thing for 2013. Well, all we need to do is go back to the first process. We can change this to 2013. And now down here, run all processes. And again, it'll run all 4 processes together and put out the totals for 2013. It looks like we spent a bit more, same codes in the same sequence, but we did spend a bit more in 2013 than 2012. Okay. Now you might have realized that actually we don't need process 2 anymore. If we diagram the data flow, we'll see that process 2 puts out a table here that's not input to any future process. Remember, we skipped it when we added process 3. We went back to the output of process 1 rather than process 2, since the one was just a sort of the other. So we can actually get rid of process 2. And by the way, that's what the bolding means. The bolding means it was output but not input in any future process. These are usually considered their final outputs of the seed. And I'm going to go back now and just remove that process because it's really no longer needed. You can remove that process. You can move any sequence of processes. And you notice these process names don't, this is process 1, now it says process 3, because you can rename this to anything you want to be more descriptive in what your seed is doing, but we're not going to bother with that right now. Okay, now one other thing we might want to do is want to modify this seed, let's say, for to actually look at the top providers as opposed to the top HCPCS codes. So back here, if we simply go back to the first process and change this to the NPI, okay, and then in this process, instead of the HCPCS reference, we want to bring in the physician reference. Now we're doing, I'm going to bring in the physician reference by here, this physician's reference. And what I'm going to do is I'm going to copy the name and then go over here and rename this and with the name of the physician reference in place of the HCPCS reference. Now we need to refresh this these fields because HCPCS code is no longer in physician reference, so we want to bring in NPI here, and here we want to bring in the NPI here instead of the description. And instead of the description, I'm going to bring in the provider name. And so in the last process, I'm also going to refresh this by saying putting the NPI here and the provider name here. And now we've modified this to get the top providers with their names as opposed to the top procedures with the descriptions. I'm going to simply run all the processes, and we'll see. It will only take a minute, or sorry, 3.5 seconds. And now we see that the top provider is Millennium Health, who was paid $211 million in 2013. Okay, so perhaps the next step that we might want to do is to find out what that top provider received the money for. So let's add another process and bring in the seed output from that last one. I'm not going to say add all tables. I'm just going to say OK. I'm going to go over here, bring in the physician HCPCS utilization table, and I am going to add all columns. Now I'm going to go back to the first table, and remember this first table is an output of the third process, and that process is a sorted list of the providers by the total amount paid in 2013. So in this process, I want to bring in the first record from that table. I'm going to do that by saying I want to get only the first row to the first row. Just bring in the first row. In the range, that's called the range filter, the input range. And I'm going to bring in the NPI and the year, which now you see have an asterisk in these two fields. I'm going to join on the NPI and the year. And now I'm going to do an extract rows join at an output. Here I have to change the output name a little bit in order to avoid duplicate file names because of the process I deleted. And simply run this process. And now we have 30 rows of data which represent all of the services rendered by the highest paid provider in 2013 by Medicare. And you can see these are all lab tests. If you remember, that provider was Millennium, which is a lab company. So here we have developed in a very short amount of time a seed that does a number of things, and we've modified it to do something different than it was intended. Very easy process. With a very little training, anybody can learn to do this without any problem at all. So this concludes the brief overview of the E Development Studio.